In question 14, we're going to talk about the mensuration and the similar figures. So first of all, we have these two solid metal hemisphere, and the ratio of the total surface area is going to be 9:16, and the radius of the larger one is going to be 12. So we try to draw these figures out. This is the first hemisphere, this is the second hemisphere, and the radius for the small one, I don't know it, so I give a small r, and the big one is going to be 12. So now we're going to try to find out what is the volume of the small hemisphere. So first of all, as the total surface areas ratio, the A psi divided by A die is equal to 9/16, which means that the radius ratio is going to be the square root of it. So the radius small divided by the radius big is equal to 3/4. So I take the square root of this 9/16. So as the bigger one is equal to 12, so we have the small r equal to 3/4 times 12, giving you 9. And we can using the formula of the hemisphere, which is 1/2 times 4/3 times pi r cubed, which is gonna giving you, so 9 cubed times 4 divided by 6, giving you 486 pi cm cubed. So that's for part A. And for part B, the two hemisphere is melted and recast into two solid right circular cone. So now this two thing adding up is going to be changed to becomes two solid cone. Okay, and denotes this two circular cone by A and B. And then it is given that the height of the circular cone A, the height is 32, and the radius is going to be 5. And if the height of B is going to be 34, are they similar? So if you want them to be similar, there's actually their radius, the length, the ratio of their length should be the same, and then the volume ratio is going to be the cube of the length ratio. So first of all, we're trying to find out what is the volume of each of them. So first of all, as the volume of these two adding up is equal to the volume of these two adding up. So now we can say, now we do the part B. So we have the volume of the larger one is going to be equal to 1/2 times 4/3 times pi times 12 cubed, because the larger radius is going to be 12. So use your calculator, we have, this is equal to 1152 pi cm cubed. So the total volume is equal to 1152 pi plus 486 pi, giving you 1638 pi cm cubed. And now we can using the formula, because we have the height and the radius, can using the formula of the cone to find out what is the volume of A. So the volume of A is equal to 1/3 pi r squared h. So that's giving you 1/3 pi times the radius, which is 5 squared, times the height, which is 32, giving you 32 squared. So it's 32 times 5 squared divided by 3, giving you 266 and 2/3 pi. So the VB should be equal to the remainder, the remaining volume, using the 1638 minus here. That's giving you 1371 and 1/3 pi cm cubed. So now we're trying to find the ratio. So the ratio of VB divided by VA, which is equal to 1371 and a third divided by 266 and 2/3. That's giving you 5.1425. But the ratio of the height here, this is the height ratio, isn't it? So the height ratio, so the HB divided by HA is equal to 34 divided by 32. That's giving you 1.0605. And even though you take the cube of it, so the cube of the ratio of the height is going to be the ratio of the volume. So let's take the cubed. It's going to be equal to 1.199, which is not equal to the volume ratio. So they are not similar. So because if you want them to be similar, the volumes ratio should be equal to the length ratios cubed, isn't it? And now we find out it's not the same, so that is not similar.